we'll study about what is control unit. So control unit is the unit that have power of generation
आशिक कहंदे वे तेरी लैला रंग दी काली जदा जवाब मजनू ही है। मजनू को सब मिलके पागल समझते हैं और अकेला मजनू सबको पागल समझता है। कहता है जितना
we'll study about what is control unit. So control unit is the unit that have power of generation, timing or control signal, clock signals, you may have heard about it, that controls the operation. Types of operating system, multi-program operating system, architecture requirement, and so on. Mode shifting, system calls, fork system calls, and in the end, as I have promised in the preview, problem solving. Okay, so these are the 3 textbooks which I am following for creation of this course. OS concepts by Kelvin, Tenenbaum, and Stallings. Okay, so let's start. So the first question which arises in our mind is, what is an operating system? So I'll give you several definitions and I'll explain them one by one. Okay, so operating system is an interface between user and computer. What is an interface now? I'll explain them. But first, we should know a little bit about component of hardware. Then only you will get a better idea about what does operating system basically do. Okay, so there are 3 components or 3 units of hardware: input output, memory, input output, memory, and CPU, which is also known as processor. So in CPU there are 2 units, control unit and arithmetic logic unit. Let me change the color. I think this will be good. Okay, so control unit and arithmetic logic unit. We'll study about what is control unit. So control unit is the unit that have power of generation, timing or control signal, clock signals, you may have heard about it, that controls the operation. It is also widely known for sequential execution of micro operations. Now the question arises, what are micro operations? These are the operations that are carried out on data stored on registers. Let me clarify those definitions. So this is the high level program written here: int abc, b is equals to 1, c is equals to 2, a equals to b plus c. Okay, so this is a high level statement, a macro operation. Now when it is passed on to the compiler, it converts into several micro instructions like load the value of b into register r1, load the value of b into register r1, load the value of c into register r2. Now add r1 and r2 and load the result into r1. Now store the value of r1 into memory A. So these are some micro instructions. Okay. Now the control unit is responsible for sequential execution. That is, first you have to do this, then this, then this, and then in the end this. Who is responsible? Control unit is responsible. Okay. So this was the architecture in which memory, input, output, and processor. This was now the architecture proposed by von Neumann. It is most famous architecture. Okay, so now we'll move down. So we have understood what is control unit. Now let's understand what is ALU. ALU is called functional unit. What functions is performed? It performs like arithmetic and logical functions. So it's the main unit that carries out arithmetic and logical operations. It consists of adders, subtractors, and so on. Now comes the memory part. So we have studied in our earlier classes that there are 2 types of memory: primary memory and secondary memory. Primary memory is also called as main memory, and secondary memory is also called as auxiliary memory. Primary memory includes RAM, ROM, cache, registers. It's faster to access, it's expensive, and it has lower size. And one most important thing about primary memory is it's volatile. What does volatile mean? Volatile means that the content vanishes when the power supply goes off. It doesn't happen in the secondary memory. Secondary memory is non-volatile. That is, content does not vanishes when the power supply goes off. Let's take an example. You have downloaded a movie. Now you shut down your computer. When you start again, you find the movie present there already. But let's take an example of let's say terminal. You have written some code, and then when you close the terminal, the code vanishes. It can never be brought back. So this is the primary memory, and the secondary memory are, these are the hard disk, the pen drives. These are the example of secondary memory. So we have, in the von Neumann architecture, we have written the three parts: memory, CPU, and input output. So which memory here I am referring to? I am referring here to primary memory. CPU access only primary memory. Which memory? Primary. That's why I have written P. Then what about secondary memory? I have not seen secondary memory in this architecture. Where is it? So that's why I have written it in form of question. So where is secondary memory then? So as per von Neumann architecture, secondary memory are the part of input output devices. Input output devices, I hope that you must know what are input output devices. It's like monitor, keyboard, printer, and hard disk. These are input output devices. Okay, now an important concept come here. How are programs executed in the von Neumann architecture? So this is the most important part of von Neumann architecture. You must pay a little more focus here. Okay, so let's take with an example. We started with the file test.c. So this is a C file, as here it is, we are seeing the extension .c. So it's a C file. C file is passed to the compiler. Compiler converts into the executable form, that is in form of instruction I1, I2 till IN. Let's say there are n instructions. Okay, now these instruction, this whole instruction is passed on to the operating system. What does operating system do here? It loads the .exe file into the main memory. This is an important part. So when a program is loaded in memory for execution, this concept is known as stored program concept. This is an important concept. So what does OS do? It loads the .exe file from hard disk to main memory, and then from main memory it is passed to the CPU, and CPU do the sequential execution. That is, CPU first take the instruction 1, I1 execute it, then I2, then it will execute it until a little more focus here. Okay, so let's take the extension .c. So it's a C file. C file is passed to the compiler. Compiler converts into the executable form, that is in form of instruction I1, I2 till IN. Let's say there are n instructions. Okay, now these instruction, this whole instruction is passed on to the operating system. What does operating system do here? It loads the .exe file into the main memory. This is an important part. So when a program is loaded in memory for execution, this concept is known as stored program concept. This is an important concept. So what does OS do? It loads the .exe file from hard disk to main memory, and then from main memory it is passed to the CPU, and CPU do the sequential execution. That is, CPU first take the instruction 1, I1 execute it, then I2, then it will execute it until the end instruction 1, I1 execute it, then I2, then it will execute it until in the end IN. Now the question arises, so here I have written CPU cannot execute the program directly from the hard disk. Why is it so? Why does CPU cannot directly access from the hard disk? Why does it require the main memory? Why does it require the operating system that needs that .exe file first transferred into main memory and then in CPU? Why does it happen? Because hard disks are slow. The computer has a high and fast processing speed, but it cannot fetch that much data from hard disk. It requires a fast memory. So CPU is fast, hard disk is slow. We need something that can match the speed of CPU. So this is main memory, that is RAM, and it is fast as CPU. Okay, so first operating system need to transfer .exe file to main memory here, which I have shown, and then CPU loads the program from main memory to itself and does sequential execution of the instructions. So the instruction of the program are executed sequentially one after another. That we will learn more in the computer organization architecture course. So what we have learned about the fundamental principles of von Neumann architecture, we have learned about store program concept, that is operating system loads the .exe file from hard disk to CPU, and the second point is then CPU does the sequential execution of the instructions. Any program that has to be executed must be stored in the main memory. That is the golden rule you have to remember. Okay, now you can understand what is an operating system. So here is your user, here is our hardware. So operating system acts as a bridge for communication between user and hardware. User talks in the high level language. Question arises, how does operating system perform so much of work? How does it do this work? So how it is done? So OS consists of several modules. It consists of modules like process manager, memory manager, file manager, device manager, and protection manager. All this combines and become kernel of operating system. It is also known as core or nucleus. How does it? This is just a representation. So question arises between symbol and the whole language of the computer is between the side 0 and 1, between symbol 0 and 1. Okay, this is just the representation. So question arises, how does operating system perform so much of work? How does it do this work? So how it is done? So OS consists of several modules. It consists of modules like process manager, memory manager, file manager, device manager, and protection manager. All this manager perform so much of work. How does it do this work? So how it is done? So So OS consists of several modules. It consists of modules like process manager, memory manager, file manager, device manager, and protection manager. All this combines and become kernel of operating system. It is also known as core or nucleus. Okay, so what I have taught you till now, let me put this all into the same picture. what I have taught you till now. Let me put this all into the same picture. This is our user, this is our hardware, and in between there is an interface. So these are the users I have symbolized in the cycle form, and in the bottom there's a hardware. So operating system manages the hardware and it acts as an interface. So there are two levels of interface, level 1 and level 2. Level 1 is user OS interface. That is like a command interpreter which consists of shell or GUI. Can be either. So it's a user OS interface that helps in communication between user and the OS. So the level 1 interface helps with communication between user and the OS, and then OS kernel performs the operation that is required by the user with the help or with the management of the hardware. Hardware consists of CPU, main memory, input-output devices. What is OS kernel? OS kernel consists of all these modules: process manager, memory manager, file manager, device manager, and protection manager. Okay, so this was operating system definition number 1. Now let's move to definition number 2, that is operating system also act as resource manager. So which resources I'm talking about? I'm talking about software resources and hardware resources. Hardware resources include CPU, monitors, input-output devices, and software resources are file, semaphore, monitors. So you don't need to worry. There's no need to worry. We'll explain all of them, file, semaphore, monitors, in detail when the time will come. Okay. And the second part is control program. It acts as a control program. Let me also tell you one thing. In resource management, operating system perform the allocation of resources, deallocation of resources, freeing of resources, etc. Basically, it manages the resources. Which resources? Hardware and software. Operating system act as a control program, a program that control all the operations of the computer. Definition number 4, set of utilities to simplify application development. It takes charge of hardware, create environment or platform that help us to focus on development in the high level mode. So what OS will do? OS will perform the work at the back of the stage and will help or will allow us to write the code in the high level language, and rest OS will manage. We just have to write the code in high level language. So this is the power of operating system. So if I summarize, what is an operating system? Operating system is a government. So government is not a single person. We cannot say, let's say Joe Biden is the government of America. No, we don't say it like that. We say government consists of lots of ministries, like Ministry of Health, Ministry of Defense, Ministry of Science. So operating system is like a government. It consists of several ministries, or we can say modules. Which modules I'm talking about? I'm talking about the modules in the kernel, like process manager, file manager, etc. So operating system is not a single program. Operating system is a service provider, just like the government. Operating system is the resource manager, just like the government. So who manages the resources in the country? Government. Who provides the service to the people? Government. Okay. So government controls the country. In the same way, OS controls everything in the computer. Okay. So let me explain you again. So user, it communicates to the application of program. Application of program goes to the kernel, operating system kernel. Then at the lowest level, it is hardware, memory, or devices. Okay. So now the question arises, in the introduction we should also study what are the goals of operating system. Operating system, there are several to study. Okay. So now the question arises, in the introduction we should also study what are the goals of operating system. Operating system, there are several goals, like convenience, that is the primary goal of day-to-day operating system, which we talk about. And then efficiency. Efficiency means you should use your operating system, make use of resources efficiently. It should be reliable. It means for which purpose operating system was designed, that purpose should be achieved. What is robustness? Operating system should be robust. Robust means strong enough to bear errors. Operating system should be scalable. Operating system should have ability to evolve. Operating system should be portable. It means it should have ability to work across different platforms. Let me give an example. A Windows operating system, that is more portable than Mac operating system. Mac operating system only works in the Apple devices, whereas Windows operating system can work in number of devices like Samsung, Dell, etc. Okay. So as I've said, what is the primary goal of operating system? The convenience. So there was a survey taken that which operating system would you prefer, Unix or Windows? Most of the people have chosen Windows. Why? Because it was convenient. Even though Unix was more efficient, Unix was more reliable, it was more robust. So the primary goal of operating system. I'm not saying all operating system. Why? Because there are some different operating system like real-time operating system, which have some deadline strict programs like we say missile control, satellite control, nuclear system, or let's say air traffic control. So all of these things have a strict deadline. So these are known as hard real-time operating system. Okay, and the soft can be said to as ATM, in which a deadline is strict deadline. Even if it is not met, then it's not a big problem. So in these cases, here the main goal is reliability or efficiency. In a missile system, in a missile control, satellite control, nuclear system, air traffic control, efficiency and reliability are the main goal. Here convenience do not matter. Okay, so it depends from operating system to operating system that which is its primary goal. Either it is convenience or efficiency or reliability and so on. What are the functions of operating system? Processor management. These are all self-explanatory functions. It manages the processor, memory, it detects the error, it's responsible for the security and file management, and will in detail I will explain them all in detail when we move ahead to this module of processor management to memory management. These are all chapters. Okay, so this is the first lecture. Let us revise what we have done. We started with what is an operating system. It's an interface between user and computer. Components of hardware is memory, input output, and CPU. CPU consists of two: control unit and arithmetic logic unit. Control unit is responsible for control signals that controls the operation and sequential execution of micro operations. Micro operations are the operations that are carried out on data stored in registers. Okay, we have taken an example, and then we understood what is ALU and then memory, the two types of memory. We have also understood where is the secondary memory in von Neumann architecture, how programs are executed in von Neumann architecture. This is an important part. We've learned about stored program concept and sequential execution concept. Any program that has to be executed, we've also learned this, must be stored in the main memory. Then this we have learned how operating system act as a government. Okay, this is the communication. How does it communicates the user to hardware? There are two levels of interfaces we have seen. We have also understood how operating system act as a resource manager. What are resources which we are here referring to? Control program, application development, simplification. It acts like a government. And then goals and functions of operating system. So in the next lecture, we'll study types of operating system. Hello everyone, welcome to the operating system course, lecture 2. In this lecture, we are going to study mainly about the multi-programming operating system. We are not going to discuss those operating system which could be understood just by the Google search. So our main focus is understanding multi-programming operating system. We'll start with the introduction and then we'll lecture, we are going to study mainly about the multi-programming operating system. We are not going to discuss those operating system which could be understood just by the Google search. So our main focus is understanding multi-programming operating system. We'll start with the introduction and then we'll move in depth. Okay, so these operating system which are batch operating system, multi-program, time sharing, real time, these are basic operating system, and distributed OS and network OS are advanced operating system which is also known as multi-processor operating system.